We are going to have a look at what do we mean by par rate bonds. Now, it's a very common concept in the bond market. So, par rate refers to the coupon rate. So, when we talk about a par rate, basically what we are saying is a par rate is the coupon rate of the fixed rate bond when the cash flows of the bond are discounted. So that means all the coupons and the final notional, when they are discounted, the present value of the bond will be equal to its notional. So simply, when we are talking about a par rate bond, what we are saying is the bond's coupon is such that if all the coupons and the principal is discounted to today, the bond's price will be equal to its notional. So here, let's assume we have a bond which has 2 years to mature. It's a fixed rate bond with a coupon rate of C, paying semi-annual payments. So that means every 6 months the bond will pay C by 2, because remember, when we are given a coupon rate, normally it's for a year. So when we are saying the coupon rate of C paying semi-annual payments every 6 months, it will pay us half of this, and as a notional of $100. So if it's a 2-year bond, we have 4 payments, 4 6-month payments from now: 6 months, 1 year, 1.5 years, and 2 years. So every 6 months we will be getting C divided by 2. That will be the cash flow. Remember, I'm not multiplying this by 100 because the notional, because we are assuming this bond has a notional of $100. So you can say C% divided by 2 multiplied by $100, and that will take off the percentage sign, so it's simply C by 2. So every 6 months you will receive the coupon. It's a fixed rate bond, remember. And finally, at the end of 2 years, you will receive the final coupon plus its notional, $100. Now let's assume these are the different discount rates. So D 6 months is a 6 months discount rate. D 1 year is the 1 year discount rate. D 1.5 years is the 1.5 years discount rate, and D 2 years is the 2 year discount rate. Now you can calculate these discount rates using the risk-free interest rate curve. Some banks use the LIBOR curve as the risk-free interest rate, and some organizations now increasingly they use the overnight index swap rate as the risk-free rate. And so risk-free rate, you could use a particular reference interest rate. So if we are saying that this bond is a par bond, basically what that means is, in order to calculate the par rate, remember we said the par rate is the coupon rate. So we are trying to calculate C, where the present value of the bond should equal to its notional of 100. So here we are simply multiplying each cash flow by the discount factor. So C by 2 is that cash flow multiplied by the D 0.5, means the 0.5, I'm just saying that's half year. So that's the half year discount factor. That's this. The same way we are multiplying C by 2 by D1, that's the 1 year discount factor. Again, the third coupon we are multiplying by the 1.5 years discount factor, and the final coupon payment we are multiplying it by the 2 year discount factor. Plus we have a notional of $100. Finally, we multiply that by the 2 year discount factor. So if this is a par rate bond, the present value of all these cash flows should equal to its notional. So if we solve this formula, and assuming that we have the discount rates, then we can easily calculate C, which is the par rate. So remember, when we talk about the par rate, what we are saying is that's the coupon rate on a fixed rate bond when the net present value, or the price of the bond, equal to its notional. This becomes very helpful when you value interest rate swaps, and I'm just going to briefly touch on this because there's a separate session I did on derivatives valuations where I discussed quite extensively on valuing interest rate swaps. So I'm going to briefly mention that here. So in a plain vanilla interest rate swap, now in this this is a plain vanilla interest rate swap where I have shown you in the blue box here. So these are cash flows. So these ones are fixed cash flows. So in this interest rate swap, we are receiving fixed interest payments and we are paying floating interest payments. So floating interest rate payments I've shown you in dotted lines. Now, an interest rate swap such as this, you can assume this as each leg of the swap, you can assume them as an individual bond. So the floating leg of the swap, you can assume this as a floating rate bond, and the fixed leg of the swap, you can assume it as a fixed rate bond. So if you're thinking why we are doing this, I discussed this in detail in the interest rate swap. When we talked about interest rate swaps, valuing interest rate swaps as bonds, you can have a look at that. So remember, at the inception of the swap, the value of a swap equals 0. In other words, when you enter into a transaction, as most derivatives, the time you enter into the transaction, the value of that derivative equals 0. So if we are saying at inception of the swap, the value of the swap is 0, what we are saying is, remember, we can value a swap as the difference between a fixed rate bond and a floating rate bond. Now here I'm adding the fixed rate bond is because we are receiving fixed cash flows, and I'm deducting the floating rate bond is because we are paying floating cash flows. If it was the other way around, you will have the signs in the opposite direction. But here, because we are receiving fixed rates, so I'm adding the fixed rate bond and I'm deducting the floating rate bond. So the present value of the swap is basically fixed rate bond minus floating rate bond. But we are saying at inception, the value of the swap equals 0. Now we also know at inception, remember, at inception, the present value of the floating leg, in other words, the present value of the floating rate bond equal to its notional value. So at inception, the present value of the floating rate bond equal to its notional value. So that means if the present value of the floating leg equals to its notional value, since we know that, remember, at inception, the value of the swap is 0. That means these two values should be equal at inception. So if we are saying the floating rate bond's value equal to its notional, that means the fixed rate bond should be equal to its notional as well. So that's what I'm showing here. The present value of the fixed leg equal to the present value of the floating leg equal to its notional value. So I'm saying this is only true at inception. In other words, when you enter into the trade, not at other times. So when you enter into the trade, the present value of the fixed leg equal to the present value of the floating leg equal to its notional value. So now that means, because remember we are saying the present value of the fixed rate bond equal to the notional of the bond. So this is the same definition when we spoke about par rates. Remember, in par rates we said if we discount these cash flows and if the present value of these cash flows equal to the notional of the bond, then we can say the coupon of this bond is the par rate. So that's the same definition here. At inception, again remember, at inception, if we are saying the present value of the fixed rate bond, that's this here, equal to its notional, equal to the notional of the bond, then we can say the par rate of this bond is equal to the swap rate. Remember, swap rate is the interest rate of the fixed leg. So in a nutshell, what I'm trying to say is, in this slide here, at inception, basically the swap rate is the par rate. So remember, when we talk about swap rates, what we are trying to say is swap rate is the fixed interest rate in an interest rate swap attached to the fixed leg of the swap. So here, the interest rate that is attached to these interest payments, remember this is a fixed rate because it says receive fixed, that is called the swap rate. So the swap rate is the par rate. So that's something to remember. So remember, when we talk about par rates, par rate is basically the coupon rate of the fixed rate bond. So par rate is simply the coupon rate of a fixed rate bond when the cash flows of the bond are discounted to the present value. The bond's price will be equal to its notional.